Good morning and welcome to Past Performance Virtual Chapter, or good afternoon or evening, wherever you may be. We are very excited to kick off the Performance Palooza Day today. We got John Sterrett with us, and we will be bringing him up in just a minute. We're going to cover just a few quick topics before we get started. Moderator today is actually Leslie Weed, but we do have Ryan Adams on also. Information about the Past Performance Virtual Chapter. We've got our Twitter, the website, discussion list, and email. Please feel free to reach out to us if you have any questions or need information. Here's a little bit of information about GoToMeeting so that you have any questions. You can look at this for assistance. If you require assistance, you can raise your hand. How to maximize your screen with the Zoom button. And if you need to type in questions, we're going to do questions at the end. So feel free to type in a question at any time, but be aware that we will not address it until the end of the hour. So we have a big day today. Let's get to the next slide here. We want to thank our sponsor, SolarWinds. This is very important. This allows us to host these webinars and have fantastic speakers on, so they will be giving away a gift card today, and we thank our sponsors for this. This is very important. Quick, coming up, Past Summit 2015 in Seattle. If you have not been to this event, try to go to this event. This is a fantastic event. Lots of people go to this, lots of SQL Server and BI professionals, people that you work with and know and can share things with. Lots of technical topics from both DBA to BI and development and professional networking. So lots of good stuff here. At the bottom, you will see a discount code that you can use for this year. Feel free. This is also posted on our website, so if you are not registering today but later this week and need to reference that discount code, you can go back to our website and get this code. So hope to see you in Seattle this year. So our day today. Lots of great topics, lots of speakers. If you need to come back and reference this, again, grab our URL down here, our website, so that you can go back and see our list for today. So starting off the day, we have John Sterrett with Make Your SQL Server Queries Go Faster. Very excited. I'm going to go ahead and change him over as our presenter. And John, you can take it away.
Excellent. Thank you, Leslie. And let me make sure we have the right screen over here. So Ryan and Leslie, are you guys able to see my PowerPoint deck?
Yes, looks good.
Excellent. All right. Well, I am excited and thrilled to kick off this wonderful 8-hour dive on performance tuning. And to start us off here, we're going to go over an hour presentation on some tips and tricks that can be very helpful for helping you make your SQL Server queries go faster. So I hope everyone that's attending today is interested in making their queries go faster. So I'm John Sterrett. I'm an independent consultant that does a lot of work with performance tuning. So if anyone has any questions in that area, always feel free to reach out to me via email, my blog, or Twitter, and I would love to talk with you to see if there's any way I can help you out. So, as I mentioned, I'm an independent consultant. There's various ways that you can get a hold of me, but I am a huge believer in the past community. I've been around for a very long time. I run the HADR virtual chapter in case anyone over there catches any of those. I'm one of the guys in the background that helps keep that running for you. And I also run the Austin local user group here in Texas. But for work, I do tons and tons of work with performance tuning, HADR, and today we're going to be focusing a lot on performance tuning. So as a member in the community, I actually love being an attendee. So whenever I'm watching sessions, I always want to be able to get as much material as I can and watch and learn during the presentation instead of write everything down. So because of that, I've provided this link where currently right now, if you want to, you can go ahead and grab all the demo scripts we're going to go through, the slide deck, and there's even a recorded version of this presentation out there too. And also make sure to give this out to Leslie and Ryan too, so that way they can send it out in any email blasts or put it up on the Performance Virtual Chapter website. So here's basically what we're going to cover. I'm going to cover a lot of common mistakes I see repeated over and over and over again out in the field, and go over a lot of great things that developers, IT pros, and even junior to mid-level DBAs should really know about performance tuning. So we're going to cover exactly how can you really identify what is your root cause to some of your performance issues. So we're going to go over how you can actually capture a workload and aggregate that workload without writing a single line of code. So we're going to go through some basic examples on how I go through and baseline our queries, right? Because as you identify your top offenders, you're going to want to go out there and see if you can fix them. So in order to do that, you have to have a really good process on how you're going to baseline your queries before and after you're making changes, so you can know how much better your changes are making that query or how they're actually making it worse, and I'll show you exactly how I recommend doing this in non-production environments. Through that process, we'll also dig in and look at some execution plans. We'll go over some repeated scenarios I see that are good and bad and ugly about indexing. And then finally, where we'll spend the bulk of our time, we're actually going to dive into what I would call T-SQL anti-patterns. And so I started my career out as a developer. I worked in what I would call the Microsoft potluck. So I did classic ASP, ASP.NET, 1.0, all the way up to 3.5, and even started off with SharePoint. And I became a performance tuner because I wrote code that was functional and did what it was supposed to, but it took a long time. And I had to figure out, well, how do I make it go faster? And through that process, I found a lot of patterns that seem to be very friendly for developers, but tend to not be so friendly for the optimizer itself. So we're going to spend quite a bit of time going through and identifying some of these patterns, and then also give you a way on how you can rewrite those patterns so they're more optimizer friendly. So just to kind of also recap, if you're an expert who does a lot of work with performance tuning, this session may not be for you. So with that, we'll go ahead and we'll get started here. So these are the demos that we're going to walk through. To start off here, we're going to go off with finding your top offenders by using extended events. So if you have 2012 or above, you could do all this without writing a single line of code. After we do that, then we're going to go through a couple examples of patterns to look for and how to make them better. So we'll start off with our benchmarking example, which we'll go through looking at the bookmark lookup there, which we'll go through some indexing. But then from there, we're going to go all into T-SQL patterns. So we'll look at inline scalar functions, sargability, table variables versus temp tables, CTEs, exist versus count, and then implicit conversions. So to start us off here, root cause analysis for SQL Server. To a lot of people, it is an experience very similar to this, except the needle isn't right in front of us, right? It's somewhere deep in a haystack, and we're digging around, and we're doing knee-jerk metrics to kind of figure out what should we be looking at. And one of the things we're going to go through right now is how anyone using SQL Server 2012 can use extended events to help aggregate a workload to kind of find what are the top offenders for CPU, duration, reads, and writes without even having to write a single line of code. So with that, we'll jump into our first demo here. We're going to go into Management Studio. So I have an instance here of 2012 on my local laptop here. And if you've never seen extended events before, under your instance, when you get in there, you can go straight into Management here, Extended Events, and then here's a bunch of extended events that I already have here, and we'll walk through how you can go ahead and create one to go ahead and see and capture your top offenders for a workload. So the very first thing I would recommend if you're going to create one here is to actually go ahead and do the new session instead of the wizard. So, and this may seem counterintuitive, but the actual new session is a wizard that gives you a lot more control than the actual wizard itself. So when we go ahead and we load this up, we're just going to go ahead and give it a name here. performance VC here. And next from there, we're going to go ahead and say that we want our blank template, and we're going to go to events. So this is where we're going to have to configure events that we would want to trigger to capture data based upon. So even if you have no idea which events you would want to use to be able to find your workload, if you have statements that are running, they're usually going to end up completing. And when they complete, that's when you can get metrics about how long they ran. So just by typing in complete up here in the top library window, you're going to see that we're automatically filtering over here and only pulling back events that have complete inside of it. So even though there's hundreds of extended events you can choose from, this is a quick, easy way to filter and be able to find the events that you would want to look at. So from here, we can go ahead and click on one here, like SQL batch completed. And this will give you more details about it. So we can see that this occurs when a T-SQL batch has finished, and then we can also see some of the fields that are included in it. So for example, duration, CPU, logical reads, physical reads, and even the text here, so the text of the statement that's in there. So we'll go ahead and we'll pick this one. So to pick it, we're going to go ahead and click on the arrow here to add it as a selected event. The other one I would recommend looking at here is SQL statement completed. So if we have a stored procedure or even an object that has multiple statements in it, so for example, a stored procedure will say 20 select statements inside of it. This SQL statement completed will give you the completed metrics for the statements inside those objects. So I would recommend grabbing these two here. So now from here, we can go ahead and go over to configure. And this will allow us to add global fields. So these are global properties that can be tagged along to your events that you selected. And if we actually go here and we hold control, you can select as many events that you want. So that way, as you want to add global fields, it'll add them to all the events. And the reason why we're doing this is because there's one global field that you definitely want to make sure that you add. And that is going to be our, let's stay this out here, our query hash. And the reason why, if you look at this right here, this will give you an identifier for queries with similar logic. So what this means is, if you have statements that are very similar, so even if you have ad hoc statements that are coming through a vendor app where you can't change the code, and they have statements all throughout their application that may be select star from table, where column 1 equals, and then you have different parameters, this will aggregate all of that represented as one ID. So that way, when we're capturing our workload, we can aggregate that and treat that all as one type of statement so we can find out if that's something that we want to look into. So this is going to add it, and you can see back over here, because we have both selected here, we see 1, which means that that field was added here. So for filters, this is where you can add more filters in here. So for example, you may want to cut out a lot of the low-hanging fruit that you wouldn't want to tune at all. So you can add filters, for example, if duration is less than 5 milliseconds or anything in here that you would want. But for the purpose of our demo here today, we're going to go ahead and skip this. So now that we have our events and we know what we want to capture, the next thing we have to determine is, okay, what are we going to do with that data? So here are different kinds of storage options. And for these events, the two that are most commonly used would be event file and ring buffer. So ring buffer is a nice fancy way of saying just store it in memory so it's not persisted. If we stop the extended event, we'll lose everything that's out there in memory, where event file will store it to actual file that will be persisted that we can then take to another server to use and do analysis on. So for here, we're just going to go ahead and have this go out to ring buffer, and this is where you would have more properties on size, how much memory that would be used for it. And then finally, there's advanced properties over here. So for today, we'll keep this with the defaults with a single event loss. And then once, if we want, you could go ahead and script this out. So that way, you have a copy of this, so if you have multiple servers where you would want to make sure that you have the same extended event on, you can use this to deploy it through many tools like Central Management Server that comes with SQL Server. Or, like I said, we can go ahead and already have this running. So while this is going on here and scripting it out, due to the amount of time today, we actually have a version that's ready for us with data that's captured. So you can see here's the script that's created for it. If I go back over here, we could just say OK, and it would create it or run the script here. So as you can see now, we go over and refresh. We didn't tell this to start running, so you can see that we have our red arrow here. We can easily do that through here if we wanted to. So that way you can start and stop it, or you can even do it through T-SQL as needed. But here's an example of the output that you typically see. And if you've used Profiler before, this probably looks similar to you, and you may be wondering, well, why is this so much better? Well, one of the reasons why I love extended events, especially 2012 and 2014, is because I have that query hash, I can now do grouping. So remember that query hash is that unique identifier for statements. So as soon as I add grouping on this, we're going to see everything got grouped in together. So even though there are a bunch of statements that were ran, there really was basically a couple of statements that just ran very frequently. So here we can see that we had 500. If we extend this out, we're going to see this insert statement over here. And the same thing for the other two that are in here. So we have some different kind of statements that are going on as part of this process that got captured. Now the next best thing here is we can then aggregate all this. So for example, if we wanted to find total amount of reads, total CPU, total duration, we could do that, or we can also do min, average. And then we can also tell, well, how do we want to sort this data for us? So we can see right here that we're able to easily pick up all of these, and we're going to sum on them. And then we also here have our options for how to aggregate the data. So for here, we'll just do duration and descending order. So that way, we're going to get those ones that took the total most time to run, no matter how many times they ran. And very quickly, you'll see that it already aggregates that for you. So this will kind of get you to that scenario where if you capture a workload, hopefully you're going to find a few statements that are way above the rest in your pain point that you're looking at, whether it's duration, CPU, reads or writes. So that way you can focus your time on the queries that need the most help. And that's one of the biggest mistakes I see out the field is people won't do this, and someone may come to them and say something is slow, and that statement can end up being a symptom of a bigger problem. So you definitely want to be able to know how you can capture a workload and be able to aggregate it so you're focusing on the statements that are causing you the most pain. All right, so now that we've kind of gone through and we've figured out, okay, how do we find our top offenders? The next thing that we're going to want to do is be able to figure out, okay, well, how do we benchmark them so that way we know how to compare these statements? And that's where we're going to go through next. We're going to go through, and I'm going to show you how I go through and do benchmarking of queries. I'm going to show you what I look at with execution plans here, with set statistics, and also how I get my same starting point. And then we'll also go through the bookmark lookup where I'll show you some examples of mistakes that I see with indexing also. So first thing here, I'm going to go ahead and make sure we're using our database in here. I do a little cleanup just in case I have these in here. Good, and they failed because they already were clean. So how do I start my starting point? So whenever I'm doing query tuning, ideally I always want to do it not in production because I never want to be adding pain where there's already a problem that we want to be looking at and fixing. So what I'll do is I'll try to spin up or have another environment that's as identical as possible with the data and objects and schema. And then what I'll do is I'll do my work over there. And to start off, there's three things that I want to end up doing. So to get the same consistent starting point, I want to always assume worst case because this is the same thing the optimizer is going to do when it's building execution plans for you. So I want to assume that I have nothing in memory, so no data and also no execution plans. So the very first thing I'm going to do is a checkpoint. And the reason why is because there is no command to drop dirty buffers. So you can only drop clean buffers. So what the checkpoint will do is it'll flush them out. So that way when we drop our clean buffers, we can remove as much as possible. And then also, I'm going to free proc cache because what I want to do is also get plans out. Now, if you want to, you can do it for individual statements, as I've given an example below here, but just for testing and non-production here, I'm just going to go ahead and do these three to get my worst case scenario for starting. So once again, only do this in non-production. You really don't want to be doing this in production because you will be causing issues because everything is faster when it's in memory for your plans and your data, and you're basically throwing it all in the trash can here. So never do this in production when you're baselining. So the next thing I'm going to do here is I'm going to go ahead and turn on set statistics. So this will allow me to get metrics for how much I/O, whether the I/O was already in memory or we had to pull it from disk. And we're also going to be able to get our time here. So we can figure out how much time was spent in the CPU and how much was spent total to bring everything back to you. So next we're going to start with two simple queries that are almost identical. So the very first one here is our select star from a table. We have no filter across, so we'll get every single column. And then we're going to go ahead and clear everything out so we have our same starting point. And then we're going to do the same thing, except we're only going to get 3 columns. So this is how I'm going to go through and show you exactly how I go about benchmarking here. So the other thing I'm going to do is I'm going to go ahead and turn on the included execution plan, which you can see right here. There's also estimated right here. So this would actually get you an estimate of the plan without actually fully running the query. But for today, we're going to mainly focus on the actual plans here. So let's go ahead and run these. We'll see here that it'll take a little while. So even if you've never looked at an execution plan before, SQL Server is a cost-based optimizer, so it'll give you costs for the actual operators in here and the total query. So if you have 2 queries running side by side, one thing you could do in most cases is just go ahead and run them and look and see how the cost is different. So from the execution plan statement here, we're not going to really see any differences here. We see that we're doing our clustered index scan, which may seem like a good thing, but the actual icons here are pretty useful because what this is telling you is you have a clustered index, but you're scanning across everything in it, which is why you can see we have our arrow going like this. And we have the same thing both. So this looks pretty much exactly the same. So let's go ahead and actually now look at our set statistics information. So I'm going to go ahead and zoom in here, but I want to shrink this down. So the first thing you'd want to make sure here is you have your same row count here. So here we can see we have our row count. The interesting thing to note here is regardless of doing select all and selecting a few columns, we're reading the same amount of pages because we're using our same clustered index. We also have a physical read here. And we have a physical read here, and the reason why, again, is remember we did our worst case scenario. All this stuff in the middle is our commands to go ahead and throw everything out of memory. The other thing to point out here is that we're doing a read ahead here. So we're actually reading from disk once, and we're doing a read ahead to pull in all the other pages that are needed here. So the other thing to look here would be the actual time. So here we can see that the first time this ran, here's how much CPU time was required and also how much duration total that it took to run. And you can see cases where CPU is actually higher than the elapsed total time. That's usually cases where you've gone parallel. The whole time of parallel is added up in there, and it's usually more than your total execution time. And then here's an exact opposite of the other one. So in the other case here, the only thing that we really see that is completely different here is the elapsed time due to how much data is being sent back and forth. So that's basically in a nutshell how I would go about benchmarking queries as I'm going through the tuning process. You can see there that I focused on execution plans. I looked at the set statistics, I/O, and also the time in there. So now we're going to dive into the index tuning. So we're going to have the same query, except here we're adding our where clause in here, where we're going to filter by last name. So one thing that you can do when you're starting out here, you want to look and see, well, what's currently out there to help us for indexes. So you could do Alt F1 or run sp help because that's the shortcut for it. And what this will do is it'll give you a bunch of information about the table, including the indexes that are out there. And there's quite a few scripts out there that can get you a lot of information. But the main thing I wanted to point out there was there's no index out here on last name. So to go ahead and start again here, we're going to clear everything out. We're going to go ahead and run our query here. And we're going to see a couple of things that we want to point out here. So once again, we're still doing our clustered index scans. We're scanning across our whole clustered index. We also see what's known here as a missing index hint recommendation. And a mistake I see, which we're going to go through in this demo, is a lot of times people will see these every time they're troubleshooting and automatically add them. And this doesn't do a good job of looking and seeing, well, what do you currently have in place and how can that be tweaked? So that way you can use the same index for multiple queries instead of having a whole bunch of indexes that are partial duplicates. So here we go, and we can see that we have that in there. If we go back over, we're going to see the exact same thing we saw where we have our I/O here. So we can see that starting off, we have 3,816 logical reads that are occurring. So let's go ahead and add an index. So we're filtering off last name. So a thought that may come into mind is let's go ahead and we'll add an index over here on last name so we can help our filter. So go ahead and we'll do that. And then we're going to go ahead and rerun our same query in here. So, and we're going to see that now we have a different execution plan. And looking first, we can see if we're looking at I/O here, that we went down from 3,800 to 300, so that's there by a factor of 10. Also, because we added our index, you're going to see that we have compile time. So we recompiled the statement because of the index change in there. So if we go back over to the execution plan, and this is exactly why we're seeing a different execution plan in here. So there's a couple of things I want to point out. First, we have our index seek here, which is great, but we also have a couple other things going on here. We have a key lookup. So basically, we have columns here. So we had our filter in the index on last name, but we didn't have first name included at all in the index. So we have to go to this key lookup down here to pull our first name. And because of that, we're using an operator, which is our nested loop here. So for all the developers that are on this presentation, if you've never heard of a nested loop, all this is a for loop. So every single thing that comes through here, so this is for I equals 0, I less than length, and go through until you get through everything. It's going to go through and do everything down here based on every single row up in here. So, and you can see that here. So if we hover on and we go into this, we can see that this basically is the same language you would expect for a for loop. For each row in the top outer input, scan the bottom. So, and same thing that we can see on the key lookup here. On our output list, that first name column here is the reason why we have to do this key lookup, because it's not part of our index. So here is an easy, good way on how you could solve that. What we're going to do is we're going to recreate that index, but we're going to actually include first name, so it's a covered index. What this means is that last name will be used for filtering, but first name will be tagged along in here. So that way it could be added so it could cover the select part of the query. So we'll go ahead and we'll run this. And now we're going to run the same query again. And we're going to see that we have our new execution plan. And now we went straight down to an index seek. So this here is going to tell you that we're scanning a particular range and pulling the data that we need. So this is the best operator you're going to see. And this is validated again here by looking at the fact that now we're only doing 4 logical reads. So this is great. But now we're going to get to where this can start to go a little bit downhill. So let's assume that you have multiple queries that are very similar coming in from your app. And here's an example where we're going to add another column. And you may have, say, 30 or 100 columns in the table, and there's so many different queries with different columns added that could be using the same filter. What happens now when we have this scenario? You're going to see that we're going back to that key lookup over here because our new column we added called middle name is not included in there. So what do I see often done out in the field is that people will just say, okay, or DPA or a tool that they may be using to help them with looking at indexes, we'll tell them to just go ahead and let's create another one. So here we go in here, and we're just going to create another index. I even added 2 to it. And it's the same thing except we're adding the middle name in there to make it covered. So obviously when we run this again, we're going to see the same thing here. We're going to see that we went back to our single index seek, and we're down to 3 reads. So this may look like it's great, but the problem is now we have overlapping indexes, which means we have more indexes than we truly need, and these have to be maintained. So every time you're doing inserts, updates, and deletes, they all have to be maintained. And as you add more and more of these can also make it harder for the optimizer to find really good execution plans for you. So I'm going to run this next query, which is going to identify those partial duplicates. And here's going to see exactly our scenario here where here is our first index and here's our second one, where in reality we could just keep the second one and it'll solve both queries. So never blindly just go ahead and implement the indexes as you see them pop up in execution plans or through DMVs or even through a tool like the Data Tuning Advisor. So here we're going to go ahead and clear it out. You can see that basically I just go ahead and dropped, and actually what we could have done here was just drop the first one. There really wasn't a need to recreate the second one because it already had both in there. But just to prove to you there's no smoking mirrors here, now that we only have the second one, that same index will end up being used for both of these queries in here. So as we bring this up here, you're going to see here that we're doing our same index seek across the same index here. So you can see there that our index middle 2, then even down here, index middle 2. So that was our object that's used. So definitely make sure that you're doing a good job of looking at what indexes are currently out there, because I constantly see cases where I see factors of more indexes than even columns in tables. So next we're going to go ahead and we're going to start diving into those anti-patterns here for the last 30 minutes of our session in here today.
So hey John, before you start that section, just a couple of quick questions. One is, what version of SQL Server are you using?
Oh, okay, yeah, so for this we're on 2012 in here.
Okay. I had somebody ask, just because they're probably not familiar with it, is what is drop clean buffers and free proc cache?
Sure, so great question. So let me go back over here so we can pull up in here. So the drop clean buffer buffers. What this will do, we want to do the checkpoint over here first because this is going to take dirty pages, so pages that have been changed. So when you go ahead and you update, you change data, it can stay in memory before it physically gets written to the actual data files itself, and that's what's kind of known as a dirty page out there in memory. So we do the checkpoint so that way it'll flush those and it'll persist them out to the data files. And at that point, you don't have dirty pages. So the drop clean buffers, what this does here is this will then take all the clean pages, so the pages that haven't changed and aren't different from the data files, and it'll remove them from memory, the buffer pool. So that way you don't have them in memory anymore. So you're starting from a state where you're assuming that there's no clean pages out there in memory. So that's why we're doing that in non-production. So we're starting from the exact same spot, which is our worst case scenario of having no data pages in memory. Where the free proc cache now is it's freeing the actual plans that are in memory. So it's just wiping out all the plans there. So you're at that same starting point where you're assuming the worst case of, I don't have an execution plan, so I have to recreate it.
Cool. I'll let you continue on. Thank you.
No problem. All right, so now we're going to dive into a pattern that I constantly see over and over, and it was one of my favorites when I was a developer, because as a developer, I love object-oriented code, right? So I don't want to have to sit there and have the same statements all throughout many different places. I'd rather just have, a function that I can use and just call that function over and over again. So we're going to actually look at a simple scalar function in here. I'm going to go ahead and start us off, make sure we're in our AdventureWorks 2012 database. We have our IO and time on. I have our execution plan. And what we're going to do here, and just to clean up in case this is here, I'm going to go ahead and drop them. We've got our message because it's not there. So all this function is going to do is it's going to get a max product quantity right here from my sales order detail enlarged table. Now keep this in mind because I'm actually going to also show you a case where this is a good pattern to watch out for, because you're going to see misleading information through our benchmarking procedure that we're going to walk through. But the whole point here is for a product that we're going to pass in, we're going to figure out the max order quantity and then return it. So we're going to go ahead and we're going to run this. Once again, we're setting up our baseline, so you'll see this repeated often here. We're assuming worst case, so we're trying to throw all the data pages and the plans out. Never do this in production. This is for benchmarking in non-production. And then we have some great comments in here for myself. So what I'm going to want to do here is I have an extended event that's running, and I'm just going to turn it on for live watch. And the reason why you'll see here very shortly. So as I come back here, we're going to run this statement. So I'm going to have a select product, and then I'm going to use that function we just created, that scalar function, and I'm going to put product ID in there. So what's going to happen here behind the scenes is for every single row, we're going to call this function, and this is going to cause row-by-row processing. So we have our execution plan here, and I'm going to go ahead and fire this off. And we're going to see this is going to take a little while. And while this is doing this, I'm going to flip over here because in our extended event, we're going to see that this is being pumped row by row. So for every row in that table that's pumping through here, you're going to see this happen row by row throughout. And the reason why we're looking at our extended event is because when this wraps up here, we're going to see that all of our information in here from our sales order detail enlarged table, it's not going to be included in here. So as it's just finished, it took 30 seconds. We're going to see our execution plan, and you're going to see that enlarged table isn't even in here. We just have our table that we're going against. And also, if you look at set statistics here, we're going to see here that it only shows 4. And that's because it's only going across product. So everything in that scalar function that's going row by row, we wouldn't even see unless we had a profiler or extended event trace that was running to show it. So as you can see, once again, for every single row, we're doing row by row processing and calling that function. And you can see that took 30 seconds. So that's a pattern you want to be able to identify. So now that we've identified it, what can we do to make this run much better? One option for you is we could go ahead and create a table function, user-defined function. So this is going to allow us to use set-based logic to process everything as a set instead of going to row-by-row processing. So we're going to actually return a table back, and now we're going to go ahead and pass in the product. So it will pass in a set of product IDs and then allow us to do this across the whole entire set. So we'll get the max per the set in there. So we'll go ahead and we'll create our user-defined table function in here. And we're going to go ahead and once again get that same starting point. So hopefully this will really drive this home like a hammer here. As you're doing this in non-production, right, we want to have that worst case scenario starting point so that way we're comparing and we're doing it safely by comparing apples versus apples here. So we do that to get our same starting point. And now we're going to have a little bit of a different statement. So as I'm looking in here, we're going to see that now we're doing a cross apply here because we're going to basically take all of the product IDs of the table here that's coming in and use that to do set-based logic to get us our max quantity back out here. So when we run this, and remember it took us 30 seconds initially for this thing to run. And just by doing that one little switch there of making a scalar function be a table value function, we went from 20 to 5 seconds. And on top of that, we're going to see a couple other things in here. Most importantly, oops, sorry, stopped my zoom in too quickly here. We have everything. So we have our sales order details and large information. The other nice thing is here we actually went parallel because of our cost was high enough and we weren't prohibited by the scalar function, which wouldn't allow us to go parallel anyway. So if we go over here, we can see that we have all of our information in here. So there's a couple things I wanted to point out here. One, this is an edge case where you can get misleading information if you're just only solely focusing on the execution plan and set statistics IO if you're using scalar functions. We actually had to have that extended event, or you could use profiler if you had a 2005 or 2000 as your instance of SQL. So not only did it do that, but also if you see that scalar functions are used, one thing you could do is just switch them over to user-defined table functions so you can do set logic instead of row-by-row processing. All right, so next we're going to go in and we're going to look at sargability here. And what I'm going to show you is quite a few cases where the statements you write, because the way they're written, may be non-sargable. And what non-sargable basically means is even though I have an index here, I may not be able to use it just because the optimizer isn't able to seek and it's forcing it to scan. And so here's just a real easy beginning basic example that kind of continues from our bookmark example. So the one thing we're doing here is we have a wildcard here in front of Smith. So what this means is I basically want to find any people that have a last name where the word Smith is some part of the name. So for example, we may have someone with a hyphenated name where Smith isn't the first part of the name. So when we run this, this is going to force us to be non-sargable. So even though we have that index in there, let me go ahead and get the execution plan and run that again. We're going to see here we're using that index. But we're scanning, we're not seeking. And the reason why is because it doesn't know how to eliminate through the B tree. So, but here's just another example. If you were able to say where last name starts with Smith, now it knows, okay, I can go through the tree and find out things that are before it and just skip it. So that way I can seek through. And so for here, we're going to see that we're seeking. And we can see that our read count there is much smaller because we're seeking instead of scanning. So next we're going to look at quite a few different examples of this. So out there on the web, there's lots of websites that may have some functionality to where you can kind of drill down by how a name starts. So for example, by every letter in the alphabet. And there's multiple ways how you can do this. So the first one, we're going to use Substring here. And this is what I see a lot out in the field, where we're going to say, give me last name. Let me zoom in here. And we're going to see here that we have our function here, Substring. We're going to have our last name. And this is going to tell us we want to get one character and start with the first character. And we want it to be equal to S. So this is basically saying, get me any person that has a last name that starts with S. So why this is what I see a lot out in the field. If you just rewrite this a little bit different to where you're not using that function and you just have a last name like S, and then you have your wildcard, we're going to see the second one becomes sargable and the first one's not sargable. So as we run these side by side, we're going to see a huge difference between the two of them. So once again, this over here is 89% of our cost, and we're scanning because this is non-sargable. This is that case where we have our function in there that's being wrapped around the last name. So we have to manipulate the data first, and that's going to make it non-sargable for us. Where over here, we're going to see this is a much lower cost, and we are seeking because we're not doing anything to our column here, and it's written in a way where we could say, hey, you know, just start where S is, and we'll start probing from there and get everything we need and then stop. So we'll go through a couple more examples just like that. So if you're working with date, a lot of times I'll see cases where people have date time, but they're basically just trying to strap out the date out of it, even though we now have date and time data types. So here's an example where I'm showing you a lot of times where I'll see people do case converts over here. And because of that, we're going to have to scan. We even have, so another thing you want to look at with your execution plans is any cases where you see the little warning sign over here. So by looking at this here, we are going to see that we have our warning, and this is telling us that our cardinality estimates may be off because we're doing conversions in here. And all this is doing is just being able to allow us to filter by that date. So how can we do this without having to do any of the conversions and to keep this sargable? Well, there's two common ways I see out there in the field, and there's a big difference between them. And these are them here. So for example, on the first one here, we're going to say modify date where it's greater than or equal to, and this will be the very first time slot in this date. So that way we could say and where it's less than the very first time slot on the next day. So this will get us every single record on this day here. So the second one, while this is still sargable, there's a big difference between the two. And because we're using between, it will actually also include this value. So it's not less than, it's going to include this too. So when we run both of these, while the execution plans look good, the one thing you will notice here is the actual data is different. That we can see, first of all, we would expect the same cost over here. But when we go and look at our set statistics, this is where we're going to see in our initial run, we have 26 rows, and here, switch this over to red for bad, that we have a different row count. And the reason why, if we look at our results here, this is actually going to include that first point on the next day as we scroll down here towards the bottom. So once again, if you're wanting to pull data for just a date period range, definitely do less than equals and less than here instead of between, because you will actually also get this value in there as part of your set. So same thing working with dates. What if we want all the data for a year? Once again, what I see commonly out there is we'll do year of the column equals this, which is very easy to write and smaller to write from T-SQL, but this is going to be non-sargable, where if you actually want this to run faster, switch this over to doing less than equal to the first date, and this would be the first time slice of 2008, and less than the first date there in 2009. So as we run these, you're going to quickly see the same thing over here. So sargable, non-sargable. So once again, this is what I see out there in the field. This is a quick, easy way how you can rewrite that to make it run faster if you got the index that it can use for seeking. So same thing over here with date year. What I'm showing you here is I'm switching where we're adding our functions here. So instead of doing it on our column, I'm doing it on the scalar that we're passing in. This will give you the same result over there. And then also same thing here for doing cases where you want to have multiple options for passing in, like reporting, for example. If you have, let's say you want to pass in a value and you want to say if sale order equals that value, or if you want to say if that's not even there, then just have it equal itself. And one thing I want to point out is there are some T-SQL functions that will still be sargable. So the one thing I want to point out here is we're still seeking here because is null is an exception to the rule where this is one of the functions that actually will allow you to still be sargable. So with that, we're going to go ahead and hop over to the next one, which is going to be our temp tables versus table variables. And same thing, we're going to do our setup here. And there's a couple things I want to point out between the differences of temp tables and table variables. So the first thing out on the internet, and you'll see this quite a bit, is that with table variables here, you'll see that you can't have any indexes on there. And I want to show you, as you're defining your table variable, you can actually have a clustered primary key index out here. So here basically we're just going to dump some data and then we're going to go ahead and filter it here. And we're going to do the same thing with our temp table. And if there's only one single thing that you take from the comparisons of table variables with temp tables, this is what I want it to be for you. If you're going to use a table variable, up until 2014, it's always going to assume one single row. There are some changes with the cardinality estimator to where it gives you a fixed number that it uses. That's a little bit higher, but the main point is it's always not going to give you real statistics that you're using on the table variable, unless one scenario here where we're actually using option recompile. So I don't see this often in the field because there's overhead because you'd have to recompile the statement every time it ran. But this is just to show you that there is an exception to the rule. Here we're going to see that we now have our stats there. So the next thing is we're doing the exact same thing here, except we're using a temp table. So when I go ahead and I run this, we have two differences that I want to point out. One, we have our stats, but also over here, we have statistics in here. So we have our statistics here, and the operator actually even changed because of the statistics here. So if you're working with real small sets of data, then you can see some advantages with table variables. But if you're working with bigger sets of data, you probably want to stick with looking at temp tables. So I know we're closing in here on time, so I want to go through one more, and then we'll go ahead and we'll go kick it back over to questions here. So the next one that we're going to go ahead and take a look at will be a good one here with exist and with versus count. So I see this over and over out in the field where there will be code where this is kind of the fork in the road to where you go down very separate paths and types of objects like stored procedures. And we're going to go ahead and select the count here because we want to basically just check and say, hey, if there's records, let's go do something. And this is probably going to be a whole lot of code. It's not going to be just print records exist. But this is what we're doing for our quick little demo here. So I'm going to go ahead and use our database in here, and then we're going to go ahead and run this. Let's run on our execution plan. And here we're going to see that we have to scan across and go through the whole entire table because we are doing our select count here. So what you can do is use if exists, and this is a terminating operator. So what's going to happen here is as soon as it finds a single record in here, it's going to go ahead and stop. So even if it's going to do a scan, it'll still stop on the very first record that it finds. So we can see when we run this, it only reads 3 pages until it finds its record. And even though we're scanning here, so we're not doing an index seek, we're still scanning across everything, but because this is now a condition with query because of our if exists, we're actually able to stop right here. So as soon as it finds a record, and obviously it's going to estimate 1 row because the first time it finds a condition that'll allow it to stop, it'll terminate the operation. So that's another pattern that you want to go out and look for. And with that, Leslie and Ryan, I'll go ahead and turn it over to you in case we have a couple questions that we can answer quickly.
Yeah, we do have just a few. Let me scroll back up here just a little bit. The inclusive versus non-inclusive search by date is fixed by understanding the logic and setting the parameters correctly. Is that correct? Having your search set between 0000 and 23,
yes.
59, 59?
Yes, you have to know that that means it will include that last value that's in there on betweens, it's included in there. So as long as that's valid for you, that's perfectly fine. I see in the field a lot of times where people don't understand that. So that's the one thing I wanted to point out there.
Great.
So, yeah.
Okay, why is the U.S. default collation CI case insensitive and some other countries use CS? Does this affect performance?
So that's a question so I'll try to answer that quickly here. And it doesn't have to be country-based. So whenever you install SQL or add a database, you can specify the collation. And basically the difference between those is case-sensitive or case-insensitive. So there are impacts, especially if you have to compare and go in between them. But that's there's a lot more I would want to talk with that person about understanding on what they're trying to do there that wouldn't fit in our time here for this. Okay. So that person, if they're still on, they can email me at johnstarrett@gmail.com. I'll be more than happy to talk to them more about it.
Fantastic. Okay, for temp table versus table variable, what is the typical data set size that you start seeing temp tables being more beneficial?
Great question. And it really depends on a lot of different things on your specific environment and the hardware you're using. Like I said before, usually when I know that I'm working with sets that are always going to be extremely small, that's where I tend to use table variables more, but it's going to kind of depend more on the workload and what's provided by hardware for the instance also. There's a lot of different factors I'd want to look at to give a specific number for someone.
Yeah, the great it depends item,
yep.
Huh?
Yep.
Okay, so one more. When do you think index scan is better than index seek?
Great question. So there's a couple scenarios where an actual scan across the index isn't a concern for you. There's 2 big edge cases. One is if your table is really small, even if you have an index, you probably may be scanning across it just because it's so small, there's no benefit from going either way. Another edge case could be if, for example, you're selecting a lot of data out of a table. So even if you have a table with quite a bit of data, if you, for example, don't have a filter like in the beginning, it can actually be better and faster for you to scan across that table instead of doing seek. So if you wanted to benchmark, I didn't cover it in here because I wanted to keep this more of a junior beginning level, you could put in index hints. So that way if you wanted to, you could force it in on production to do the seek, and you could do your benchmarking to see the differences between those. But usually cases where there's very small data or cases where you're pulling the majority of the data out of the table are cases where you'll end up seeing that scans are actually good for you.
Okay. Fantastic. We are at time, and because we have a full day of Palooza, I'm going to have to cut off questions. John, thank you so much for joining us. For those that are still sending in questions, please feel free to reach out to John via his email that he provided. I'm sure he'll be more than happy to answer those questions. There's a lot of good ones coming in. On the chat window, you will see the link to the next session coming up. John has his information there posted on the screen right now for those that want to write that down. To join the next session, you do have to go out and actually close out this webinar and go to the next webinar. John, thank you so much again for joining us.
No problem. Glad to be here. And if anyone wants to send me emails with questions, feel free to do so, and I'll be glad to talk to you and try to help you and point you in the right direction.
Awesome. Thanks so much. I'm going to go ahead and stop the recording now, and we are all done. So, John, have a great day, and hope to see you at Summit.
Yeah, I'm looking forward to that, Leslie. Looking forward to meeting you and seeing you there in person.
Absolutely, absolutely. Lots of great kudos on the question window for the presentation, and I really enjoyed it also.
Awesome, great. Glad to hear that.
Good. Okay, thanks so much, and we'll have the recording and the link out to your stuff on our virtual performance chapter website within the next week, just so everybody knows. And we'll be done, and I'll go ahead and close this out.
All righty.
Have a great day. Thank you. Bye.